Vibration of string fixed at both ends described by this equation. Okay, standing wave. Okay. What is the maximum displacement of particle at x equal to something? इसमें x put करो, what you get? 17 upon 6 pi, which is like what? 2 pi plus 5 pi upon 6, which is okay. Sine of 5 pi upon 6 is the same thing as sine of pi upon 6, which is 1 upon 2. So just 5 upon 2 millimeter. That's the amplitude. A तो easy था. Just 5 upon 2 millimeter. और क्या है B? B is what are the wavelengths and wave speeds of two transverse waves that combine to give about oh yeah, okay. So ये जो चीज़ है वो 2a है और ये क्या है, just ये ओमेगा है, ये अपना सॉरी ये अपना k है, ये ओमेगा है, then c is just omega upon k if I believe. Yeah, I think that was the thing, right? Omega, no, okay, omega upon k, right? That was c. So अपने को ये चीज़ अपॉन ये चीज़ करनी है, मतलब कि 314 अपॉन, so centimeter per second में आएगा ना, because those are the units. pi फिर ऊपर 2 आ जाएगा, 3.14 approximately just 100 हो जाएगी, 100 times 2, 200 centimeter per second, or like 2 meter per second. Next question, 32. Okay, a slender rod of non-uniform cross-sectional length L, Young's modulus Y. Okay, find the elastic potential energy stored in the rod if it's stretched by x naught. D stands for the diameter. Oh, diameter. You don't mean the radius. ठीक है, इसका डायमीटर d है, it is stretched by x naught. अपने को ढूंढनी है potential energy. I mean the whole thing, whole system, right? Oh, I mean you can just figure out individual potential energy, I guess. Whatever, just figure out key. Yeah, but like, should I just do half kx for both of these guys? I guess I can. Okay, like half kx. That's just the force. So kx is just the force, and that's x of all of these guys, right? Okay, okay. So like I'm going to for some force, what will be the x value? Let's figure that out. Suppose to our tension T है, then you just have T upon the area. So अपना stress देखना है. इसका एरिया कितना होगा? pi d upon 2 का स्क्वायर like 4, फिर नीचे pi d स्क्वायर आएगा. Okay, this upon the Young's modulus is our strain. Actually, you know what? First of all, figure out इसका भी stress निकाल लेते हैं. So just T same tension रहेगा upon area कितना जाएगा? pi d upon 4 कर सकते हैं, pi d स्क्वायर ऊपर 16. Stress, okay, got it. फिर उसके बाद में divide by Young's modulus, so you get the strain. Then distance of L upon 2, because that will give us the delta x thing, right? So you know, right, मतलब जो तुम्हारा x value रहेगी just this thing for any in fact t, right? Oh, okay, then you can think of the combined thing as a single spring, right? Okay, तो ये कैसा हो जाएगा? Just well 2 plus, is this 12 or what? No, it should not be 12, it's 16 because यहाँ पे 4 आया था ना. Yeah, it should be 8 plus 2, which is 10. So just 10 t L upon pi d square Young's modulus. Okay, so the tension is what? Tension is just pi d square Young's modulus upon 10 L times x. So ये अपना k है, we just want half kx because you know like integration of t dx. Yeah, that's the energy, just right. Find a place question is not if it's stretched by x naught, right? Just half k, k ये होगा, so okay, that's x squared. So like इसीलिए ये चीज x square by 20 आ जाएगा, right? That's the thing. So just that's our answer. Pi d square Young's modulus x naught का square upon 20L. Next question, 33. 33 is a level controller is shown in the figure. I don't know उसका मतलब क्या होता है. It consists of thin circular plug of diameter 10 cm. Okay, तो क्या plug यानी? अच्छा ये चीज thin circular plug. What's a plug? Oh right, just like वो bathtub वगैरह में plug देता है वैसा कुछ. Okay, whatever. It consists of a thin circular plug of diameter 10 cm and cylindrical float of diameter 20 cm. ये float है 20 cm का, tied together the light rigid rod of length 10 cm. तो प्लग का मतलब क्या? अच्छा, तो यहाँ से तुम्हारे साथ नॉर्मल फोर्स आ रहा होगा, राइट, फ्रॉम दिस सरफेस. इसके अंदर वाटर वगैरह नहीं होगा ना? और इज इट देयर अ लेवल कंट्रोलर? आई डोंट नो व्हाट दैट मींस. लेवल कंट्रोलर. Okay, the plug fits in snugly in a drain hole at the bottom. Okay, so hole है मतलब यहाँ पे exposed है air से, right? Okay, I thought यहाँ पे normal force रहेगा, नहीं यहाँ पे actually ये air से exposed है. Okay, as the water fills up and the level reaches the height h, the plug opens. Find h. तो जब plug open हो रहा है मतलब कि क्या कि it's just about to open, तब क्या हो रहा है कि यहाँ का right. Okay, the force on this complete body is 0 और उसमें normal force में include नहीं कर रहा because normal force is 0, right? That's a necessary condition. The float has mass of 3 kg and the plug may be assumed to be massless. ठीक है, तो फ्लोट को तुम्हें मास दिया है, प्लग में भी assumed to be massless. ओके, तो यहाँ पे जो प्रेशर वाटर का आएगा और यहाँ पे नीचे एटमॉस्फेयर प्रेशर है, राइट? सो जस्ट रो जी एच इज द प्रेशर डिफरेंस. ओके, सो रो जी एच और क्रॉस सेक्शन एरिया सिलेंड्रिकल फ्लोट तो डायमीटर दिया है. गॉड, दैट्स नाइस. ओके, तो यहाँ पे भी ऊपर प्रेशर लगेगा, राइट? बिकॉज ऑफ दिस गाय. इंटरेस्टिंग. The plug fits is at the bottom of the tank as the water fills up, the level reaches the right edge. The plug opens. I get it, I get it. तो इसमें तुम ऊपर फोर्स लगा रहे हो बिकॉज ऑफ रो जी, ये जो भी हाइट रहेगी, एंड देन ओके दैट्स जस्ट रो जी और एच माइनस 10 यहाँ पे है, एंड देन रो जी एच, ये डाउनवर्ड प्रेशर रहेगा, एंड देन इज अपवर्ड प्रेशर, एक्सेस प्रेशर बेसिकली कंपेरेटिव टू एटमॉस्फेयर, बिकॉज एटमॉस्फेयर ऊपर नीचे से कैंसिल हो ही रहा है. सो या इट्स लाइक रो जी 10 का प्रेशर डिफरेंस है ना थ्रू आउट दिस. और जो क्रॉस सेक्शन है इसका क्या, उनका डायमीटर अलग अलग है. फाइन. सो थिन सर्कुलर प्लग ऑफ डायमीटर 10 सेंटीमीटर, जो रेडियस प्लग है कॉल आर पी, दैट इज जस्ट 5 सेंटीमीटर, लाइक 5 10 पावर 82. अपने को सब कुछ करना क्या है, एच आई थिंक यू वांट इन सेंटीमीटर, अपन 5 सेंटीमीटर कर देगा, 5 सेंटीमीटर. और क्या है, द रेडियस ऑफ आवर फ्लोट इज 20 centimeter. Okay, so just radius क्या होगा, 10 centimeter, right? Okay, cool. Tie together light and jet rod of 10. Okay, plug fits in. Okay, in slugly in a 10. हाँ समझ गया ना, water fills up, right? So you know कि इस पे जो पूरे सिस्टम पे फोर्सेस है, जस्ट buoyant force because of this, मतलब बेसिकली यहाँ से जो प्रेशर फोर्स आ रहा है वो माइनस यहाँ से जो प्रेशर फोर्स आ रहा है वो तो कैंसिल हो गए, और यहाँ से जो प्रेशर फोर्स आ रहा है, गॉट इट, राइट? मतलब वो फोर्स कैंसिल नहीं हुआ एग्जैक्टली बिकॉज, but then अपने को वो पी नॉट अपन जीरो अज्यूम कर सकते हैं, राइट? ओके, फ्लोट हैज मास ऑफ 3 kg एंड द प्लग मे बी अज्यूम टू बी मासलेस. फ्लोट का मास भी है, ओह शिट, तो ग्रेविटी भी इस पे ऐड कर रही है. राइट, ठीक है ना, जस्ट डू दिस थिंग. सो इस पे प्रेशर फोर्सेस कितने आने वाले, फ्लोट पे इज जस्ट पाई आर फ्लोट का स्क्वायर दैट टाइम्स रो जी, ओके दैट्स रो जी, रो वाटर ऑफ कोर्स, and then h minus 10 centimeter. Okay, that's awesome. That's in the upward direction. Okay, cool. फिर और अपने को दिस इज इक्वल टू जो भी डाउनवर्ड फोर्सेस हो गए, तो इसमें डाउनवर्ड फोर्स लग रहा है विच इज जस्ट पाई आर प्लग का स्क्वायर एंड देन रो जी एंड देन यू जस्ट हैव एच, राइट? दिस रो जी एच, या सो एक्स स्पेशल इज दैट. ओके कूल. और फिर प्लस इस पे डाउनवर्ड फोर्स लग रहा है ग्रेविटी इटसेल्फ, तो इसका मास 3 kg जस्ट 3 times g और 3 kg times g. या आई गेस दिस शुड वर्क. सो जी तो गया हर जगह से, ये जा रहा है, इट्स बेसिकली दिस थिंग. कूल. सो अब क्या, शिट वी वांट एवरीथिंग इन एसआई यूनिट्स थिंग्स, सो तुम्हें करना ही पड़ेगा ना, या एसआई यूनिट्स. ओह नहीं, फर्स्ट व्हाट वी कैन यूज लाइक, ओके आरएफ इज जस्ट 10 एंड आरपी दैट, आरपी से डिवाइड कर दो इस जगह पे. और इनफैक्ट लाइक ओके, अगर ये चीज नहीं होती देन इट विल बी डूएबल, बट यू विल हैव टू एक्चुअली डू इट. उफ. एंड व्हाट डू यू वांट, जस्ट वांट एच बाय द वे, फाइंड एच. ओके, हाँ राइट, वी हैव टू कन्वर्ट दिस, जस्ट नो एस्केप. ठीक है, जस्ट डिवाइड बाय दिस फैक्टर. तो ये क्या हो जाएगा, जस्ट आर एफ अपॉन आर पी का स्क्वायर विच हैपन्स टू बी 2 स्क्वायर लाइक 4 टाइम्स ऑफ एच माइनस 10 सेंटीमीटर इज इक्वल टू एच प्लस ये सारी चीज 3 kg अपॉन पाई आर पी स्क्वायर रो, राइट? चलो कैलकुलेट करो, 3 kg अपॉन पाई आर पी इज दिस थिंग इज लाइक 25 टाइम्स 10 पावर नेगेटिव 2 का स्क्वायर 10 पावर नेगेटिव 4. कुछ ऐसा यूनिट चाहिए अपने को. डेंसिटी ऑफ वाटर इज लाइक वाटर, राइट? So 1 gram per centimeter cube अपन कर सकते हैं. Oh, that's actually awesome because what that would mean is कि you don't have to write it like that. 25 centimeter square is just 1 gram per centimeter cube. तो ये हमारा एच सेंटीमीटर ऊपर चला जाएगा. यहाँ पे इसको 1000 कर तो लाइक 3000 अपॉन 25 पाई सेंटीमीटर्स, राइट? एग्जैक्टली. तो ये कितना होगा, 3000, इज दैट करेक्ट और व्हाट? क्या किया, 4 टाइम, ओके जस्ट 120 अपॉन पाई सेंटीमीटर्स. हाँ okay, interesting. ठीक है, just 120 centimeters. That's what this thing will be. This is still weird. Okay, what 25 minus 4, 120 upon pi centimeters. Okay, cool. Just have to figure out h in centimeters, of course. So क्या मिलेगा अपने को, just 3h is equal to 40 plus ये सारी चीज 20 upon pi centimeters, right? So h is what, 40 upon 3 plus 40 upon pi. Interesting. हाँ ठीक है ना, just we got the thing at least. 22.7 probably not a good idea. Just divide, no, 40 को 3.14 से divide करो. Ah, still not going good, huh? कुछ तो भी और तरह से करना पड़ेगा कुछ. पर और कोई तरीका तो है नहीं. Fine, I'm gonna put that as my answer. सेंटीमीटर्स में इतना. Centimeters. Okay, 34. 34 is thin rod of mass m attached to small ball of mass capital M. Its other end is restrained to oscillate in a vertical plane as shown in the figure. Okay, क्या ये mass m, ये mass m, small m कहाँ पर, अच्छा, rod of mass m attached to small ball of mass capital M. Other end restrained to oscillate in vertical plane. Other end क्या है? Oh, okay, like this. Find the natural frequency of oscillation for small displacement in the vertical. Initial rod is horizontal. ये जो चीज़ है यहाँ पे attached है कि क्या है? I guess this is the pivot point, जो भी है. Right. Initially, rod is find what natural frequency of oscillation for small displacements in vertical plane. Got it. So initially, rod horizontal ये जो भी इसमें जो भी force लग रहा है, just managing that, right? जब तुमने इसको थोड़ा सा displace कर दिया, then right. So यहाँ पे से जो weight आने वाला था, that's, oh god, this is kind of weird. But then तुम इसको change कर रहे हो and it's like ये नीचे चला गया जितना भी हमने displace किया, right? That causes a difference in the force, of course. So वो जो extra force है that causes the, yeah. राइट, ओके, सो जस्ट वो mg और ये जो ऑलरेडी kx नॉट था वो तो वो स्टिल टॉर्क होते कैंसिल हो गए, और ऑल यू हैव इज तुमने जो इसको नीचे पुश किया है इसमें नया फोर्स क्रिएट हुआ, व्हिच इज लाइक लेट्स जस्ट से तुमने आई डोंट नो थीटा पुश किया तुमने, राइट? देन l upon 4 theta times k, that's that force. So फिर l upon 4 का स्क्वायर लाइक l squared upon 16, right? Okay, so this is the torque, I guess, about this point divided by the inertia. Okay, कितना अपना inertia? Square upon 3 and then, oh ये complete is combined m है, right? Oh god, no, it's not going good. So ठीक है ना, m l squared upon 3, okay, squared upon 3 देखते ना क्या होता है. So पहले इसमें क्या है, m is just 3/4 times, okay, and l is also just 3/4 times, इसमें 3/4 का cube आ जाएगा, right? Yes, so just 3/4 cube, फिर यहाँ पे just 1/4 cube, I believe. Got it. Just ये अपना inertia आ जाएगा, right? Divide by this guy. So L square तो मरने वाला है, just क्या k theta upon m, क्या क्या बचा है 3 upon 16, because ये 16 नीचे आ जाएगा, and then you're dividing by this thing, right? So okay, interesting. 3 upon 16 and then in division just have this thing 3 upon 4 का square, you know 16 मर रहा है, oh नहीं cube है, upon 4 cube plus 1 upon 4 cube, ऊपर 4 cube जाएगा, just 3 times 4 upon 3 is like 27 plus 1 is just 28, right? So ये just 3 upon 7 आ जाएगा, this is, got it. Just 3 upon 7 k theta upon n, okay, so just, you know, the omega just equal to square root of 3k upon 7, I believe, because yeah, it's got a thing. It's 4 cube niche, 27 plus 1, which is 28. It just happens to be what? 7 upon 16, it's like, okay, 7 upon 3 times 16, right? So divide kar rahe ho. Upon 16 मर गया, just ऊपर 3 के 3.7, right? Yeah, okay, just that. And this should work. Just omega आपने समझ गया. What do you want? Natural frequency, this is the natural frequency. Next question. Wait, this is the angular frequency. अपने को सिर्फ frequency चाहिए ना? Or what? Natural, I mean subjective type है तो क्या फर्क पड़ता है? I don't care. So omega is just this thing, sort of. Yeah. Next question. Honestly, nahi yaar. F will just put, so F will be just upon 2 pi. यार क्या हो रहा है इसका? Just F equal to 1 upon 2 pi of this guy, right? Next 35. 35 is find the efficiency of thermodynamic process in PV diagram with the 3 moles of an ideal gas. Okay, n equal to 3 atomic. Okay, n equal to 3, F equal to 3. to find efficiency undergo cyclic process given 1 to 2 is compression. Okay, so efficiency क्या रहेगी, just work done in the whole process upon heat provided. Okay, shit, अपने को सारे करने पड़ेंगे ना. Okay, cool. So right, अपन सारे प्रोसेसेस देखने वाले. अच्छा, स्टेट्स जो है अपने, we just have to know them, right? So 1 2 3 बड़ा कर दिया. Okay, so 1 पे हमारा प्रेशर क्या रहेगा? So 1 पे तुम्हारा प्रेशर कितना है? Just this is honestly just weird. एक काम करो, थोड़ा अलग सिस्टम यूज करते हैं. So 1 is what? 1 में तुम्हारा प्रेशर क्या है? It's just P नॉट. फिर तुम्हारा वॉल्यूम इज 3 V नॉट. Okay, temperature we don't know, right? And okay, so this is like V नॉट पे सपोज T नॉट था, that's like ठीक है. so इसका से कि यहाँ पे 3 टाइम्स हो गया, like 3 T नॉट रहेगा. ठीक है, जो भी है. देन यहाँ से तुम 2 पे जाते हो. 2 पे तुम्हारा क्या प्रेशर से इज जस्ट okay, pressure is like 2 P naught, I believe. Wait, it's not 2 P naught, it's isothermal, so it should be 3 P naught, right? 3 P naught, V naught and T naught. Okay, फिर 3 पे तुम जा रहे हो, तुम्हारा क्या हो रहा है? ओ एंड साइकिल प्रोसेस, राइट? ओके, सो 3 पे तुम्हारे है 3 V naught, like okay, 3 P naught, 3 V naught, and then just have no 3 T naught, right? Because for 3 times हो चुका है. Oh shit, it should be 3 T naught already यहाँ पे, so just यहाँ पे 9 T naught आ जाएगा, right? Yes. Okay, cool. और फोर्थ पे, हाँ, फोर्थ है ही नहीं ना, जस्ट वापस अपन 1 पे जाने वाले हैं. जस्ट 1 पे वापस कितना आ जाएगा? रिपीट कर दो इसको. P नॉट, 3 V नॉट, 3 T नॉट. ओके, अब अपने को चाहिए वर्क डन एंड हीट प्रोवाइडेड एज वी गो फ्रॉम दिस टू दिस, दिस टू दिस एंड दिस टू दिस, राइट? ओके, सो पहले ट्रांजिशन में क्या तुम्हारा कांस्टेंट टेम्परेचर है, जस्ट वर्क डन इज, पर वॉल्यूम का क्या हो रहा है? कंप्रेशन. एंड आई गेस यू जस्ट वांट वर्क डन बाय द गैस, तो फिर इसमें कंप्रेशन हो, क्या फर्क पड़ता है? लाइक कंप्लीट प्रोसेस का तुम जस्ट वर्क देखो ना, राइट? व्हाटएवर. सो वर्क डन बाय द गैस कितना? जस्ट एनआरटी नेचुरल लॉग ऑफ थिंग. एनआरटी नॉट चाहिए अपने को, लाइक व्हाट? शिट आई थिंक वी शुड जस्ट 3 T naught, which is like okay, P naught V naught, okay, 3 P naught V naught actually, just yeah. NRT natural log of V2 upon V1, which is in this case like just V naught upon 3 naught, like -3. So just yeah. तो पहले इतना वर्क हुआ is just -3 P naught V naught natural log of 3. Okay, what's the heat provided? Just that much, like 3 P naught. और ऐसे वर्क डन बाय दी गैस, राइट? ओके, तो उतनी हीट अगर प्रोवाइड कर पड़ेगी, just -3 P naught V naught, just log of 3. So what's our thing now? It's like heat is equal to the work done plus delta U, right? Of course. ओके, फिर इस प्रोसेस का देखते हैं अपन. सो सेकंड में क्या हो रहा है? इट्स लाइक गोइंग फ्रॉम, अच्छा, सेम प्रेशर, जस्ट गोइंग फ्रॉम V naught to 3 V naught, जो भी है. सो व्हाट्स द वर्क इज लाइक 3, तो इसमें एक्सपेंशन है लाइक वर्क डन बाय द गैस इन दिस केस, व्हिच इज जस्ट 3 P naught times 2 V naught, so just 6 P naught V naught. What's the heat provided? Constant pressure is Cp delta T, right? So Cp is like what? इस केस में just wait, this was like nRT, right? Or ncvt? nRT, of course, that's the thing. Yeah, it's an issue of PDB, right? Yeah. और इस केस में क्या होगा? ncv, which is like f को 3 है, like 5.2. okay, और n कितना दिया है? 3. weird. हाँ, but like okay, whatever. So 5.2, फिर उसमें जो ncv delta t वो सब आएगा ना, right? 5.2 r. so just टेम्परेचर कितना है इसमें? टेम्परेचर चेंज कितना हुआ? जस्ट 6 का. So 5.6, and then we're gonna say P naught because yeah, of course. So that's the, it's the heat provided, right? Yeah, टेम्परेचर चेंज करेंगे, you just have to provide heat. And CP में तुम्हारा ये वाला फैक्टर आएगा, डेल्टा T में तुम्हारा वाला फैक्टर आएगा, and then remaining is just P naught because NR, yeah, T naught, right? Exactly. So just what? 15 P naught V naught. Okay, next. फिर तुम जा रहे हो ये ओके, थर्ड टू फर्स्ट. सो तुम्हारा वॉल्यूम कांस्टेंट इज एनसीवी डेल्टा टी, व्हिच हैपेंस टू बी लाइक नेगेटिव, जो भी. सो इस केस में क्या आएगा? 3/2, एंड देन यहाँ पे जस्ट -9 okay, -6, right? Okay, so ये चीज which is like what, -9 v naught v naught. And what's the work done? Work done 0 because constant volume. Okay, so combined work done is just 6 p naught. Okay, so it's like 6 minus 3 natural log of 3, that's the thing, upon heat given is just this thing. यहाँ पे सिर्फ positive है, everything else just negative. So upon 15, right? Yeah, which is what 60 divided by 2 minus natural log of 3 upon 5. That's the efficiency. Next question. Next is 36. 36 is a source of sound as detector are placed at the same plane on the ground. Source detector. Okay, a reflector is at height h something. At time equal to 0, source is projected with okay, with v naught vertically upward, and the reflector starts coming down. Source or detector. Wait, what? Same plane on ground. ये ground है, I assume. Okay, यहाँ पे एक reflection होता है sound का. This source and as well as is the detector. Okay, okay, whatever. ठीक है. Reflector is at height h, so भी है. Time the source is projected with v naught vertically upward, and the reflector starts coming downwards with constant speed. अच्छा, v naught. तो ये v naught से नीचे जा रहा है, and this is projected upward with v naught. If v is the velocity of sound and f is the frequency, find the frequency of sound emitted at time. Okay, and frequency of sound emitted. What? Frequency of sound directly received by detector corresponding to sound emitted in A. Okay, without reflection, of course. Frequency of sound received by the A में ना, just add t equal to something, just have to figure out what's happening, right? Exactly. So क्या है t equal to, and it's like much less than c, you are saying, so ठीक है ना. So at that point हमारे coordinates क्या हो गए reflector के? Reflector is still moving down with v naught, I believe, and source was with v naught. So उसका speed ऊपर क्या, just v naught minus. हाँ, we don't actually care about वो कहाँ पर है. We only care about कि, right? We only care about the frequencies, right? Exactly. और phase difference के बारे में we don't care. Beat, right? Yes. Sound emitted in A. Phase of sound emitted by detector after the sound. I guess, yeah. Okay, so just v naught. यहाँ पे मर गया ये. तो अब इसकी स्पीड क्या हो जाएगी, ऊपर जाएगी है, जस्ट वी नॉट माइनस वी नॉट अपॉन टू. जस्ट वी नॉट अपॉन टू अब ये ऊपर जा रहा है. हमारा जो सोर्स है गोइंग अप बाय वी नॉट अपॉन टू. हमारा डिटेक्टर यहाँ पर कहीं तो भी है, वी डोंट केयर. ये तुम्हारा जो प्लेन है इट्स मूविंग डाउन विद वी नॉट. ओके, सो डायरेक्टली रहेगा frequency of sound emitted by source at time t equal to v naught upon 2, right? Wait, emitted by the source, frequency of that. बट डॉपलर शिफ्ट है तो फिर ये अलग अलग पॉइंट्स पर अलग अलग फ्रीक्वेंसी रहेगी. तो अब क्या हाँ, weird. Source of this thing coming downward with constant speed v naught is the velocity of sound, and f naught is the frequency of source. It is still f naught, right? So sound frequency of sound emitted by source, it's still f naught. I mean, yeah, this is weird. So I don't get it. तुम frequency मतलब I think तुम डिटेक्टर के थ्रू जो आ रहा है वही बोल रहे हो, right? हाँ, A is just f naught, of course, we know that. Okay, so just B करते हैं. So directly, okay, cool. क्या रहता है, C minus V observer upon C minus V source times frequency, right? Okay, so it's f naught. So इस केस में क्या हो रहा है, just C ऐसा जा रहा है, and then V observer is stationary, just C upon F is equal to that, C plus V naught upon 2. It's not V naught, it's just C plus V observer, C plus V source. ठीक है ना? And then just C plus V naught upon 2 in this case, right? Exactly. अभी कुछ दिया नहीं है वैसे, right? हाँ. All we know is like V naught is much less than the speed of sound, and you can actually approximate this or something. But इसको नहीं करूँगा मैं. I just leave it like that, right? Okay, just 1 plus 1 upon V naught upon 2C. That's F naught, right? So that's our B. F naught upon 1 plus V naught upon 2C. Should I approximate? I don't know. और C के लिए क्या होगा? So first of all, you have to reflect this. So उस केस में it's just c minus okay, तो c ऊपर जा रहा है, your v observer is moving down like c plus v naught upon source is moving towards the, okay, so it's like c minus v not upon 2 of course, and this times अब वो frequency से वापस emit करेगा and it's like इसको reach करना चाहिए, so now the right just c minus v observer is like which is stationary upon c minus v source like c minus v naught, yeah, f naught, that's the thing of course. So yeah, we should probably just approximate, right? Yeah, so you can just 1 minus v naught upon 2c approximately. Just approximately 1 minus v naught upon 2c f naught, right? What about this guy? So इसको approximate करते हैं, it's just 1 plus v naught upon 2c फिर minus v naught upon 2c. Oh, it's not upon 2c, it's like not upon c, I guess. पहला वाला, फिर इसमें thing, फिर इसमें क्या वापस minus v naught upon c. That's it, right? So just still 1 minus v naught upon 2c approximately. Although दोनों expressions काफी अलग है, but approximately same हो रहा है for some reason. Next question. 37. 37 is whatever. Uniform spherical shell of mass m radius r starts from rest with pure rolling on long inclined plane as shown in the figure. Find angular momentum of shell about point of contact after 1 second of starting. Uniform spherical shell of mass m radius r start from rest with pure rolling on long inclined plane as shown. Find angular momentum. Okay, 1 second of starting. So after 1 second, what's the angular momentum of shell? Oh, okay, but about what point? About point of contact. So ये जो initially point of contact था, I guess. जो भी है ना, just with respect to this guy, तुम्हारे पास में क्या क्या friction forces तो कोई torque induce नहीं कर पा रहे, just basically gravity like mg sin theta times this guy. Okay, there's also mg cosine theta that you have to be worried about, but नहीं, वो normal से cancel हो रहा है, so we don't actually have to worry about that. वो yeah, that will actually cancel out because सिर्फ एक point पे इसका contact है. Okay, just mg sin theta times r, that's our torque. That's 1 second. Yeah, that was actually easy. Just mgr sin theta. Nice. Next question. 38. 38 is there's a uniform circular ring of mass m. A point mass of value m is rotated, sorry, is placed at center and is connected to a rim. Sorry, to rim by rigid massless spokes. Uniform circular ring of mass m. Point mass of value m is connected at the center. Is at the center of this ring. It's correct. Okay, got it. If the assembly is placed on a rough inclined plane, find the minimum value of cushion of friction for pure rolling. Huh? Oh, such that. Okay, okay, got it. ठीक है, so what's your alpha basically? God, this could be really complicated actually. ठीक है ना, so about the contact point, what do you have? Let's just say IC is the inertia about this center. पता नहीं कितना होगा, but we'll do it. Okay, who are we kidding? Just do it, right? Massless force is just about center. हमारा जो IC is like वो m तो गया, वो m गया, right? And it's just yeah mr squared, I guess. So फिर ठीक है. Just have friction acting and then gravity कुछ नहीं कर पा रही, just the whole torque is produced by just the friction, right? Exactly. So like f upon what's the fr upon, so the torque about it, yeah, okay, that's the thing, just fr upon this guy's inertia is like mr squared. This is equal to, so about contact point क्या, just mg sin theta times r mg r sin theta upon इसका inertia which is just mr squared plus mr squared like 2 mr squared, but एक और mr squared like 3 mr squared. Got it. मतलब कि क्या, that f should be basically equal to just g sin theta mg sin theta, sorry, upon 3, right? But we know that f is just less than or equal to mu times n, which is like mu mg cosine theta, which means that mu should be bigger than or equal to tan theta upon 3. So that's minimum coefficient of friction required. Next question, 39. 39 is uniform rod AB, mass m, length L, placed against a vertical wall of container. Now container is filled with liquid which has half of its density of the rod. Okay, if the end B is given a gentle push, then calculate the velocity of center of mass of rod when it becomes horizontal. And B is given a gentle push. Initially क्या है, it's just mass m, length L, placed against vertical wall of container. Huh. ठीक है ना. Now continuous stable liquid, which is half the density of rod. If the NP is given a gentle push, okay, calculate value of center of mass of rod when it becomes horizontal. Neglect any friction, viscosity, and kinetic energy of water molecules. Nice. Okay. What do you want? Calculate velocity of center of mass of rod when it becomes horizontal. Interesting. हाँ, जिसका जो भी वॉल्यूम रही होगी वो अब ये होगी वाटर ऊपर गया, राइट? एग्जैक्टली. Yeah, you could say so. Or you could always like talk about buoyant forces and whatnot. मास m दिया, राइट? एंड इसकी डेंसिटी तुम्हें, या ओके, और इसकी डेंसिटी तुम्हें पता नहीं क्या दी होगी. जस्ट हाफ ऑफ दैट डेंसिटी. इंटरेस्टिंग. सो यू नो mg फोर्स यूजुअली लगता है, बट देन इसमें, राइट, थ्रू आउट इट्स फॉल इस पे buoyant फोर्स ऊपर लग रहा है, राइट, एंड इट एक्चुअली एक्ट्स एज अ फील्ड काइंड ऑफ थिंग, राइट? हर पॉइंट पे यूनिफॉर्म लग रहा होगा, बस हर क्रॉस सेक्शन ऑफ वॉल्यूम पे यूनिफॉर्म लग रहा है, राइट? Guess you could say so. Or you could always do energy equations. Yeah, yeah, you could always do energy equation की जो वॉल्यूम थी अब वो रिप्लेस हो गई वाटर की वहां पे, so just you know, so इसका जो भी हाफ रो नॉट, इसकी जो भी वॉल्यूम थी, आई डोंट केयर कितनी है, so just half rho naught v. Rho naught is volume, rho is the density of the solid, so half rho v, that's that mass, right? You got g, and then h की जगह पे just h upon 2, जिसकी लेंथ होगी, ओके लेंथ है ना, l upon 2 combined उसका just, yeah, I mean x square upon 2, right? Because it's just integration of, yeah, it's just x square upon 2, so that's cool. मतलब कि इतना तुम्हारा इंक्रीज हुआ एनर्जी में, बट देन डिक्रीज, ओके, बिकॉज ऑफ दिस गाय, राइट? एक्चुअली नेगेटिव आना चाहिए दैट केस. इज वांट अ डिक्रीज इन पोटेंशियल एनर्जी ऑफ द होल सिस्टम, एंड प्लस, राइट, और ये नीचे कर गया जस्ट, सो जस्ट h upon get upon this change, it's like rho v g l, isn't that right? I guess, and this is equal to, अब जो इसकी एनर्जी आ चुकी होगी, एंड क्या ये यहाँ पे फिक्स्ड है? इट्स लाइक that can't be the case, can it be? But it is going to fall, so यहाँ पे normal force throughout is just doing that. We have to neglect friction though, so that's weird. But यहाँ पे normal force still act करने वाला है, so वो although वो कुछ energy नहीं reduce करता है, but it's still right. इसमें ओमेगा, okay, about that point there, okay, got it. Just ml squared upon 3, so okay, inertia is half inertia omega square, got it. तो करो फिर, just rho v is just the mass, so mg यहाँ पे just 1/4 आ रहा है, also actually l upon 2, okay, cool. L upon 4 mg, L upon 4 is equal to ml squared omega upon 6, right? तो ये l मरा, ये m मरा. What omega is equal to 3 upon 2 g upon l, I believe. Instead of l upon 2 is just what? 3 upon 4 g. That is the acceleration. It's not what we want. Wait a second. G upon l. Wait, is that correct? No, it can't be, right? It's omega. Wait. Omega square, sorry. Omega square is this thing, right? Exactly. So what you want is like square root निकालो इसका, just square root of 3 upon 2, then you just have square root of g upon l, and this times of l upon 2, that will be a v thing. So just, you know, square root of 6, square root of g times l, square root of 6gl. Next question, 40. 40 is, oh नहीं, जब ये 38 था, I guess, और ये क्या था? 37. और इसके दो थे, बट ये दोनों में कोई कनेक्शन तो था नहीं, तो फिर ये वॉट एवर, दिस वॉज 37 का, okay, so you know, this was A, this was B, okay, फिर 39 करना है ना. 9 is 1 mole of monatomic gas undergoes cycle process starting from 1 to 2 to 3 to 4 to 1, as shown in the temperature volume curve. Okay, plot the corresponding PV diagram. Work done by gas during the above process. Okay, whatever. Oh shit, तुम्हें actually plot करने को लगा रहे हो मुझे? Are you serious? Okay, T1 equal to 300, T2 equal to हाँ ओके, तुम्हें अलग अलग टेम्परेचर्स दिए अब इसके. दिस इज सो ओके, टी वर्सेस वी कांस्टेंट. इट्स लाइक टी 2 to 3 में तुम्हारा प्रेशर कांस्टेंट रहा है. दिस इज जस्ट नॉट गोइंग टू वर्क क्योंकि अपने को वैल्यूज तो पता है नहीं. फाइंड द वर्क डन बाय द गैस ड्यूरिंग द अबव प्रोसेस. Okay, just integration of TPV, that's the work. It's negative integration of work done by the gas station, of course. But then think about like P is what nRT upon V, atoms of dV. So ये integration करना पड़ेगा उसका. This is stupid, isn't it? Yeah. चलो ये जो चीज है इसमें कांस्टेंट वॉल्यूम है, ये तो मतलब ये तो कैंसिल ही हो गया. एंड थ्रू आउट दिस इज प्रेशर इज कांस्टेंट, राइट? या ओके, ऑसम. सो प्रेशर कांस्टेंट, ये जो फैक्टर इज कांस्टेंट थ्रू आउट. But yes, ये dB cheese. Okay, we don't want. Oh, okay. Convert volume into temperature, I guess. Okay, pressure भी तो अपने को. Ah, shit. I don't know. You will have to have the pressure thing. मैं temperature दिए है, volume नहीं दी for some reason. It's the same fucking temperature. Okay, ये volume तुम्हारी change. Ah, this is so stupid. Plot the corresponding PV diagram. ठीक है, I guess maybe PV diagram करने से मेरे को कुछ clarity मिलेगी. Maybe not. Hmm. लेट्स अज्यूम कि यहाँ पे वी नॉट था एंड देन लाइक पे कुछ और हो रहा है. ओके, एटलीस्ट यू नो कि यहाँ का जो प्रेशर था यहाँ पे प्रेशर डबल हो गया क्योंकि T2 में हमारा. ओके, हाँ वो सेकंड ना, पहले तो फर्स्ट करना पड़ेगा. प्लॉट द पीवी डायग्राम. सो 1 पे तुम्हारा कुछ भी रहेगा प्रेशर और वॉल्यूम, वी डोंट नो. 1 to 2 तुम्हारा वॉल्यूम कांस्टेंट है, इट्स द सेम थिंग. ओके, तुम्हारा प्रेशर है, आई मीन टेंशन इज इंक्रीजिंग, सो प्रेशर इज आल्सो इंक्रीजिंग, आई बिलीव. Okay, then 2 to 3 तुम्हारा pressure constant is just this. Okay, this is actually a much simpler diagram than that, right? Yeah, it's just this. Oh, awesome. Right. This is like what 1 2 फिर यहाँ पे 3 पर same pressure वॉल्यूम बढ़ रही है. यहाँ पे 4 टेम्परेचर घट रहा है, सो प्रेशर भी घटेगा. ओके, awesome. सेकंड सेकंड इज कि तुम्हारे पास में या तुम्हारे पास में टेम्परेचर दिए हुए. अच्छा, टोटल वर्क कितना हो जाएगा? इट्स जस्ट हाउ मच इज दिस वर्क. दो अलग अलग प्रेशर से यहाँ पे जो वॉल्यूम चेंज है, just V4 minus V1 that times of P2 minus P1, right? Exactly. So work done, but then how did you figure out कि क्या होने वाला है? nRT or something, right? Okay, weird. Okay, so second के लिए अपने को पहले डायग्राम को मॉडिफाई करना पड़ेगा. क्या हो रहा है फिर? 1 के इसमें so temperature is 300 Kelvin. Just V0 बोल दो इसको, just 300 Kelvin. Okay, 2 में क्या हो रहा है? It's just over here. यहाँ पे मेरा टेम्परेचर डबल हो गया. जस्ट मेरा वॉल्यूम कांस्टेंट है, जस्ट 2 V0 300 एंड देन ये चीज़ यहाँ पे 3 में 800 हो गया. सो जस्ट ओके, दिस इज काइंड ऑफ वियर्ड. मेरा प्रेशर चेंज हो रहा है, राइट? सो लाइक ये 2 था, यहाँ पे जस्ट चेंज हो गया, आई गेस. ओके, दिस इज लाइक ओह गॉड. सो 2/6 is equal to x upon 8. X is equal to what? 8/6 times this thing. Just like, seriously? Okay. So 8/3 V0. That doesn't make any sense. Oh shit, pressure constant, volume change हो रही है ना? Okay. So 2 P0 and then यहाँ पे just volume change हो रहा है, right? Okay. So V0/6 is equal to यहाँ पे जो भी आएगा upon 8. It's not 300, it's like 600 now. If that's the case, just 2 P0 रहेगा. यहाँ पे कितना होगा? अरे V0 change हो रही है. Just this is 3, this is 4, like it's just 4/3 V0. Okay, interesting. 4/3 V0, टेम्परेचर तुम्हारा 800 केल्विन है. एंड देन यहाँ पे फाइनली इट्स जस्ट T4 इक्वल टू 400 केल्विन. सो लाइक हाफ कर दो तुमने इसका. तुम्हारा वॉल्यूम सेम है, प्रेशर P हो गया. ओके, अंडरस्टूड. एंड आपको कुछ वॉल्यूम निकाल. ओके, जस्ट this area is what? 2 p naught. Okay, just single p naught. P naught times one third v naught, right? Which is like one third p naught v naught. So one third n r t naught which is 300 Kelvin. कितने हैं 1 moles? N is just 1. Yeah. So 100 R. Okay, work done by the gas. कौन से units में यार? I don't know. Just use joules or whatever. या फिर मैं कैलोरी वगैरह यूज कर सकता हूँ जो भी 8.3 approximately joules, right? 8.3 ऐसा यूनिट्स में रहता है ना? Yes. So this should be the thing like 830 around, just 830 joules. Whatever. Next question. Or like 200 calorie और जो भी रहता है. 40. 40 is a particle of mass 2 kg moving horizontal with speed of 2 meter per second strikes perpendicular to a uniform rod of mass 10 kg length 4 meter lying on a smooth horizontal surface. Particle strikes at a distance 1 meter from the center of the rod and becomes to rest. Okay, find the coefficient of resolution between the particle and the rod. Okay, uniform rod strikes perpendicular to the uniform rod. Okay, strikes at a distance 1 meter from the. तुमने उसको momentum कितना है वो दे दिया, right? Basically, yeah. So small m कितना है तुम्हारा 2 kg. स्पीड तुम्हारी जो है v नॉट इज 2, स्ट्राइक्स परपेंडिकुलर टू यूनिफॉर्म रॉड ऑफ मास 10 kg, लेंथ 4 मीटर. तो तुम बोल सकते हो ओके या पार्टिकल स्ट्राइक्स एट डिस्टेंस 1 मीटर, राइट? आर इज जस्ट 1 मीटर फ्रॉम द सेंटर ऑफ मास. ओके, एंड कम्स टू रेस्ट आफ्टर कोलिजन. फाइंडिंग, आई थिंक यू नो व्हाट आई एम गोना से कि कैपिटल R is 2. ओके, फाइंड द कोएफिशिएंट ऑफ रेसोल्यूशन बिटवीन द पार्टिकल एंड द रॉड. व्हाटएवर तुम्हारा मोमेंटम जो रहेगा, मोमेंटम इम्पार्टेड इज जस्ट mv नॉट इज लाइक 4. ओके, कूल. उतना मोमेंटम तुमने इसमें इम्पार्ट किया, इट्स लाइक v जो रहेगा फॉर दिस गाइस लाइक व्हाट, और u बोल दो उसको जो भी है. सो जस्ट u इज 10/4 से 2.5 हो जाएगा. ओके, ऑसम. तुम्हारी ओमेगा कितनी है? इट्स लाइक व्हाट्स द इनर्शिया फर्स्ट ऑफ ऑल, जस्ट mr स्क्वायर्ड अपॉन, आई मीन वी विल डू इट राइट, जस्ट ओके, mr squared upon 3 times omega. This is your angular momentum. This is equal to initial angular momentum about the center of mass, which is just mv naught small r, right? Exactly. But omega कितना है? Omega is just, wait, do you really want omega? No, you want कि वो particular distance पे. So what's omega r, right? Omega r अपने को निकालना है, which is just what? m upon capital M. 3 आ गया यहाँ पे. Okay, फिर v naught r squared upon capital R squared, right? Yes, which is like what? 3 times of ये चीज क्या हो जाएगी? 1 and then rest of v naught. V naught is 2. Assignments, I believe everything. Yes. Okay, or r upon r square, just like just 1 upon 2 squares, like okay 4. It is this thing which is what? 3/2. So ये just 3/2 है. Omega r is just 3/2 or 1.5 or whatever. Okay, तो ये जो चीज है, it's moving with 2.5 and now it's like moving with 1.5. It's like it's basically moving with what? 4, right? तो ये स्टेशनरी है, ये 4 है. रेस्ट्रिक्शन का कोएफिशिएंट कितना हुआ? You know, 4 basically. That's kind of weird. Well, E4 आ गया. Okay, wait, नहीं. Okay, V not 2 था, just 2. So E equal to 2. Cause okay, whatever. Next question. 41. 41 is figure shows the cross section of an arrangement in which light cylinder of radius r length L perpendicular plane of paper is placed on a container containing liquid of density rho. Assume liquid is incompressible non-viscous. Calculate the net force we apply to cylinder to keep it in position. Radius r, length L, okay, perpendicular plane of paper. Placed on container containing liquid of density rho. On contain, wait, what? समझ नहीं रहा हूँ मैं. Cross section of an arrangement in which a light cylinder. तो ये सिलेंडर लाइट है, ओके, लेंथ L, प्लेस्ड ऑन द कंटेनर. अब कंटेनर कौन सा है? ये कंटेनर ठीक है ना, बट ये तुमने इसके अंदर इंसर्ट किया हुआ लग रहा है. This is very weird, right? So I'm assuming कि ऊपर की surfaces तुम्हारी I guess शायद से बस खुली हुई है or something. ये समझ नहीं रहा. How does this actually even make sense कि हाँ ठीक है जो भी है, like it's inserted one quarter inside of it, right? Okay, assume the liquid is incompressible and all viscous. Calculate the net force to be applied on the cylinder to keep it in the position shown. ठीक है ना, just integration of what pressure dA, right? और वो it's going to be in this direction whatever. Okay, it's like in some radial cases and इसका अपने को डॉट लेना है with this vector. It's like इसका तुम sum कर दो ना r vector का. Exactly. It's like this not so good way of doing it. You can figure out कि vertical force कितना होने वाला है. Oh yeah, okay, split it into two kind of forces. एक तो vertical force निकालेंगे, then or you can just figure out कि area कितना है, right? And then you just do yeah in that particular case. Got it. What's the pressure? Wait, the pressure is just P naught. No, it's changing. Pressure is changing, I believe, because right. This is very weird. So kind of position shown. I don't know. मुझे समझ नहीं रहा है कि इसमें exactly क्या किया है इन लोगों ने. So I'm just gonna leave this. 42. पर ये बस ऐसा ही है and you just have to integrate. Then also it's like just a very big deal. तो अपन नहीं करेंगे. Charge placed, charge particle of Q mass and projected velocity V at an angle theta with the Z axis as shown in the ZY plane. ZY plane. Okay. From the origin of coordinates, uniform magnetic field. Okay, along the Z axis. Find coordinate of particle as a function of time. Correct. So just along. Okay, it's in the ZY plane, right? Okay, so it's in this direction that velocity never changes. Velocity क्या रहेगी? इसकी velocity है just okay v cosine theta in the z direction. That's always going to be the same. Or magnetic field is along the z direction. जो बची velocity, what's that going to be? And that's just in the y direction right now. Okay. What's the omega for that guy, right? Yeah. Just v sine theta. It's like okay, vxy is what v sine theta, and then vz is just equal to v cosine theta. Okay, and what do you want? Uniform magnetic field. Okay. Find the coordinates of particle as a function of time. First, you want to figure out the v. Right. Okay. क्या रहेगा? The force on this guy is just q v cross p. So you know like vxy देखो सिर्फ vxy vector cross p vector. p is in the okay just think of vxy as a complex number. So initial तुम्हारी vxy क्या है? So uxy बोल दो उसको. Yeah, okay, whatever. Don't. Okay, I'm just gonna assume कि vxy is a function of time. It's like we know just rotates, right? Okay. Whatever, let's do this thing, I guess. Initially इसका x coordinate क्या है? Just 0. Okay, just first of all figure out कि v कैसा है, bf कैसे करता है, and then you can do some other stuff. So vxy is what, e power, or just say I'm gonna call it like what. So मैं u बोल रहा हूँ अभी के लिए. It's just u cosine. Oh shit, what am I doing? Just u e power I, like yeah, e power I theta. So theta initially कितना था? Just along the y axis, just iota एक extra डाल दोगे इसमें, right? Just iota u e power I theta, I believe. So just theta equal to 0 पे, which is that, right? Okay, so that's how this thing. And इसका तुम cross ले रहे हो with what, k hat? Shit, can be cross with k hat. Complex number being crossed with it. Okay, just wanna rotate anti-clockwise, I believe, right? नहीं, k hat cross that. Okay, that would be anti-clockwise. This cross with k hat is usually rotating anti-clockwise. So you have to divide by iota, right? So yeah, okay. So ये जो चीज रहेगी, just this is just what, q u beta, sorry magnetic field, just u e power I theta, वो iota मर गया. This is equal to what? Oh, it's just the force. So like mass times acceleration, just a vector, right? Okay, so we got the acceleration now, yeah, which is like also dv upon dt, whatever is that, dvxy vector upon dt, just equal to what, is equal to q u b upon m. Okay, यहाँ पे u double आया क्या? No, that should not be there. Just QUB. That's it. Okay. Just QUB upon m e power I theta. You always try to integrate this thing like vxy vector is what? QUB upon m. फिर इसको integrate just यहाँ पे iota आ जाएगा, and then Oh my god. It's going to just e power I. That was a bit of constant, of course. So initially we constant hand equals was 0, right? Yeah. Initially your vector is in that direction and oof. Yeah, there's no need for that kind of constant. Because we're just assuming yes or is there necessary like a constant or something? Initially just that, right? Ah, should we just put another constant in there, like plus c upon iota जो भी रहेगा? Something's not going correct, is it? Yeah. Wait, is that correct or not? Oh, I saw that d theta upon dt, right? You also need that. Okay, you want to integrate this into what? It's time, but actually, okay, so अपने को dv upon right, we actually have to figure out कि वो कितना होने वाला है. So assuming कि अपना u ऐसा है, it's just ये बहुत लंबा होने वाला है यार. It's not making any sense. So u तो at least constant रहेगा. That's one thing we know. Magnitude guys. So it's just what iota is like negative u e power I theta d theta upon dt is equal to this guy just q u b upon m. So you know वही था जिसका यार is just what d theta upon dt is equal to ये मिल गया ना just negative q b upon m. But theta is of course that angle just making with the x-axis. So ये decreasing ऐसा बोल रहे हो b cross b of course just going in this direction. It's like okay yes it is actually decreasing so it's going in clockwise sense. Got it. So your theta is like what is just initially kitna just pi upon 2 minus q p upon m. Got it. So your v vector is given by in xy plane of course it's just I u e power I theta is like was there necessarily an I over there? I don't think so. Initially तुम्हारा theta there was no need for this I actually. Then यहाँ पे just negative की जगह पे एक iota आ जाएगा right? ओके यहाँ पे जो आई था वो हाँ स्टिल बट सेम चीज होगी ना तुम आई से डिवाइड कर रहे हो कि नहीं कर रहे हो फर्क नहीं पड़ता जस्ट दिस थिंग सब अब अपन ले रहे जस्ट v इक्वल टू दिस जैसे पाई अपॉन 2 आ रहा है लाइक आई देन u e पावर नेगेटिव q b अपॉन m टाइम्स t चाहिए था यहाँ पे एंड आई वांट x वेक्टर सो यू नो इंटीग्रेशन ऑफ दिस गाय व्हिच इज ओ इसमें आयोटा चाहिए बाय द वे yep c power I right that's why so इसको इंटीग्रेट करोगे what do you get just first of all upon negative iota or something okay which happens with negative u फिर इसको डिवाइड किया इससे just negative m u upon q b then e power negative iota q b upon m times t plus some constant so initially वो constant right okay t equal to 0 पे क्या just ये negative m u upon q b है right and we know this must be zeros like that constant is just mu upon qb. Yep, that looks correct. This is what mu upon qb times 1 minus e power negative iota qb upon m times t, which I think अपन थोड़ा change कर सकते हैं इसको in some way, right? Let me just do that or something. Nah, leave it like that. So like 1 minus cosine वगैरह तुम कर सकते हो, but this is a good enough thing. So अपने को x vector xy vector मिलता है, right? And v z is just this thing. So अपना जो z coordinate रहेगा that's just what v cosine theta times time, of course. This is the thing. So हटा दो ये. So now time to write the coordinates. तुम्हारा जो x coordinate रहेगा that's just of what form? mu upon qb just have 1 minus cosine of ये चीज right? It's cosine of qb upon क्या है qb upon m times t. Okay, y coordinate is like so क्योंकि ये ऐसे जाने वाला है right t increases ये जो चीज है like it's negative as well so it's just negative positive of course that works out of course this sign just negative नहीं, साइन यहाँ पे पॉजिटिव है, mu upon qb sine of, and by the way, what's u, just v sin theta, right? Okay, I should probably do that. Get a sine theta, like what, sine of ye cheese qb upon n times t, just have sine theta, right? So t equal to 0 0 and then z is this is going by this thing. Next question. But seriously तुम्हें ये सब क्यों निकालने की जरूरत थी? I don't understand this. It's like 3 separate questions. 43. Wireframe in the form of a sector of radius L and resistance R, free to rotate about an axis passing through the O. Through O perpendicular to plane of paper, constant and uniform magnetic field of magnitude P exists in the space above line PQ as shown in the figure. What above line PQ? हमारे पास में क्या है? Wireframe in form of sector of radius L. शायद से wireframe. Okay. Axis passing through O. Perpendicular plane of paper. Okay, or this frame is in the paper, I guess. Okay. Constant and uniform magnetic field of magnitude P exists in the space above line PQ. Okay. Direction of magnetic field in region 1 and 2 is outward and inward in the plane of paper, respectively. Sector rotates about with a constant velocity omega. Find the average power produced in the wire frame. Okay. Find the average power produced in the wire frame as it rotates, right? Interesting. So पहले तो ये just omega से rotate करेगा, it like starts entering into this thing. यहाँ पे तुम्हारा इसका flux change होगा, it causes current through this thing. फिर उसमें okay, बड़ा लंबा होने वाला नहीं? Yeah. And it's like it's 5.4, तो okay वो completely cover कर देगा. Then it starts to go into this. Seriously इसमें कितने, एक दो फिर right. Oh god. इसमें 3 केसेस अपने क्रिएट करने पड़ेंगे. That is just doesn't make sense, right? Average power produced in the wire frame. What do you mean by power? क्या I don't. It's a current flowing through it, right? Yeah. Okay, got it. Wait, and it rotates with constant. I should have seen that. Constant angular velocity omega, right? So as it is going into it, हमारा जो area increase हो रहा है, वो कितने से increase हो रहा है? Just like d theta upon dt um, upon 2 pi. Okay, I should not probably do that. Just r squared, like half r squared. Yeah, okay. Half r squared. dA upon dt क्या होगा? Half r squared. Shit. Half r squared upon dt. That's a way. Yeah, okay, that's of magnetic field. That's the current through it, of course. इतना अजीब, इसका रेजिस्टेंस क्या दिया है? टोटल रेजिस्टेंस R, जो भी है. So this is our okay, this is our flux and sigma voltage ये रहेगा constant. And upon just omega, so yeah, okay, this is actually kind of constant. So अपना जो voltage है is just PR squared omega upon 2 as it goes into this, right? And yeah, throughout its current उसमें रह रहा है. फिर अब when it goes like that, okay, फिर current उल्टा हो गया, but it's still there, right? That current is still there, of course. Yeah, okay. मतलब वो उल्टी डायरेक्शन में जा रहा है, but there's no inductance of this thing, so उसमें कोई फर्क, it can't just go in the same direction though. ठीक है ना? Then it's okay to assume कि वो उल्टा जाने वाला है. It's just very मतलब discontinuous बहुत है ये, जो भी है. Throughout your voltages is this thing. So like what? V square upon R, just P square R squared omega square upon R power 4 sigma. Okay. 4 capital R. That's the power in half a time period, right? Yes, so इसका half अपने करना पड़ेगा. So this thing is our average power. At any given moment पर उसकी power की या फिर 0. It's just half of this guy, right? कुछ दिया नहीं ना अपने को, या मतलब कुछ और, right? अच्छा, okay, instead of that, it should probably just be this thing, b square L power 4 omega square upon 8R. Next question, 44. 45 तक करेंगे, then we'll stop. 44 is photons with energy of something eject photoelectrons of photoelectric plate. When the most energetic photoelectrons enter into the region of constant magnetic field strength at angles 60 with the field direction, The maximum pitch of the helix described by the electron is found to be 2.7 millimeter. The work function of plate is this thing. Specific charge of electron is this thing. Find magnetic field strength and plot. Okay. Photon की energy कितनी दी है तुमने 3.4 electron volts. When the most energetic photons enter the region, of course, not magnetic field of the field direction. Huh? Oh, photoelectrons. Sorry. Okay. With the field direction, the maximum pitch of the helix described by the electron is found to be this thing. Pitch. Angle of 60 degree. Ah, are you serious? Okay, the work function of the plate is this thing. Specific charge of electron is this. Find the magnetic. Oh yeah, ये कितना so angle 60 degree. बढ़िया. Most just you have to figure out what u is, like just u upon 2 in that direction, and then just yes 60 degree with the field direction. I assume the field direction ऐसी है. This is like what u squared 3 upon 2 because the sine of this angle जो भी है. इसको मैं b बोल रहा हूँ अभी के लिए. So अपने क्या रहता है just you know m b squared upon r, that is just equal to, so इसका radius रहने वाला है just equal to what is equal to magnetic field times velocity times the charge of the electron. It's like E in this case, right? I guess that's the thing. Force is equal to force. Okay, got it. So EV just merge जाएगा. What do you get? Just R is equal to mv upon P times E. Okay. इस केस में just ये चीज m x squared 3 upon 2 mu upon E that's equal to R. तो करना क्या है? So अपने को R दिया है. Fine. The work function is given. So अपने को basically just have to figure out what U is. Just U is what? U is just 2RBE upon square 3M, and then you just want what? Half mu square is the kinetic energy. Just K is half mu square, which F2 आएगा, right? Okay, just 2 upon 3 square फिर उसमें M आ रहा है just okay that times of M of course नहीं नीचे M आएगा एक R squared B squared E squared. Okay, that's just for K, which is equal to our energy of photon minus the work function. So the work function is just this thing. Energy of photon minus 2/3 R squared B squared E squared upon M. Got it. Yeah, okay. This is the thing, of course. Find the magnetic field and plot the graph. Wait, that's it? Radius अपने को दिया है. The work function of plate is given. Oh, you gave us the work function. Okay. Then you just need the magnetic field. Oh, you should have told me, right? So you can say it's 2/3. Yeah, this is equal to what? The energy of photon minus work function. So 3m upon E. Square root of the square root of 3m times EP minus 5 upon 2. Okay. And then 1 upon RE. That's our magnetic field. So 1 magnetic field is this thing. Just बहुत सारा कैलकुलेशन है, उतना ही प्रॉब्लम है इसमें. I guess we just have to start. ठीक है ना? Energy of photon is this thing. The work function is what? 3 like 0.4 electron volts. यहाँ पे just 0.4 electron volts. That's the mass of the electron. It's sort of 3 upon 2. Okay. Seriously though, this is okay. And then यहाँ पे just take 1 electron अंदर जा रहा है. Okay. Charge and then radius. Radius is what? 2.7 meters. Like whatever. It's 27 times 10 power into 4. Right. So what? 1 upon 27 times 10 power into 4. उसको अंदर भेज दो. What you get? It's like 0.6 volt upon electron. I know, अजीब लग रहा है. That's the mass of the electron. I guess that should be the thing. Specific charge of electron. What? What do you mean by the specific charge? I think like, okay, I think it's just the EM. Okay, E upon M ratio, right? Or what? Okay, just 1.76 times 10 power 11 it seems. In volt तो मतलब ऐसा ही just 0.6 over there. I guess this would work. just क्या हो जाएगा 1/27 times 10^84 and this thing square root of so 6/17 1 point shit it won't work. So 11 आ रहा है right. It's not going to work. 3.4 electron volts is 3 electron volts. Yeah, give up. This won't work. कुछ से कुछ calculation है नहीं. So I put that as the answer and move on. Second is plot graph between stopping potential and the frequency of incident photons. Frequency of incident photons. Okay. Frequency to increase कर रहे हो then for stopping potential required is also like getting bigger of course. It's like that's proportional to the energy and then voltage. Okay, got it. It's proportional, right? A linear graph. So starting at what? जब तुम्हारा stopping potential 0 हो जाएगा then your frequency of incident photon is just that required to, you know, yeah, phi को nullify करने के लिए, which means it's at some level already in just that. So frequency versus stopping potential, right? Okay, whatever. 45. I know ये बहुत अजीब है but like ये मैं कैसे करूँ? There's no way I can do this. Right. Next question. 45. A diverging lens is placed with pole at origin of coordinates is shown. Equation of an incident ray is this thing. The focal length of the lens is this thing. Find the equation of divergent ray. Incident ray को मैंने दिया है. Okay. Focal length of the lens is 4 centimeter. Find equation of divergent ray. I hate it. So क्या है just x y equal to 0. X equal to what? अच्छा pole as the origin. Thanks for that at least. ठीक है. So हमारे पास में 2 पॉइंट्स इंसिडेंट रे के आने पर क्या बोल सकते हैं इंसिडेंट रे में 2 पॉइंट्स कौन से जस्ट हु केयर्स रिफ्लेक्टेड रे में 2 पॉइंट्स ही ना ये रिफ्लेक्टेड रे में पॉइंट्स क्या हो रहे हैं तो एक पॉइंट तो हो रहा है दैट इज जस्ट दिस पॉइंट व्हिच इज व्हेन x इक्वल टू 0 जस्ट y इक्वल टू 3 लाइक 0,3 एंड जो दूसरा पॉइंट होगा वी विल हैव टू फिगर आउट सो तुम्हारा जो u है u is just 6 right. Okay, so 1 upon v minus 1 upon 6 is equal to 1 upon f. Focal length कितनी है 4 centimeter. Okay, just negative 1 upon 5, right? Yeah, because you know divergent length. Okay, this is the thing. Just 1 upon v is equal to negative 1 upon 4 plus whatever. Negative 3 plus 2 is just negative 1 upon 12. So v is just negative 12. So yeah. Negative 12 comma 0 y coordinate 0 होगा. Yeah, that's the thing. So just pointing in that direction or something. So ये इसको एकदम ही ऐसा कर रहा है right? Okay, so that is really negative for some reason. Interesting. Whatever. This somehow happens to be the case. ठीक है, just yeah. And now we just want to figure out the line. Not a big deal. Okay, just x y 1 0 3 1 negative 12 0 1. So x में क्या है just 3 minus 4 तो just 3 फिर minus y में ये डिटरमिनेंट just 0 फिर minus minus like plus 12 yes yeah and then फिर plus 1 में just plus 36 right is that correct it's just 1 and then like 0 36 equal to 0 sorted 3 से divide करो that's what you get x minus 4 5 plus 12 is equal to 0 yeah so that's our answer. Next question. It's really weird. Whatever. 46. Oh no, you should actually stop here. This is it. I'll see you guys in the next video.